Mic check, mic check. Morning, Landon. How you doing? Oh, I can't hear you, Landon. Not sure why. You're muted now. Hmm. Yeah, still can't hear you. I see your mouth moving. I'm not sure if that's me or you. I'm going to do a test here. Test speaker. It's my speakers. Mic check, mic check. Yep. Hmm. We'll have to see if there's any more out there that are having trouble with their microphone. Morning, Peter. We're having trouble hearing Landon's microphone. Can you say hello to me? See if I can hear you.
Hello?
Yeah, I can hear Peter, Landon. So it must be on your end today. That's all right. Good morning, Roberto. I see you.
Hi, good morning. How are you?
Doing all right. Doing all right. Yeah, I don't know, Landon. It's okay. You can just hit me with your chat. I'll see it. There's 5 of us in here. Let's give them about 3 or 4 more minutes before we get started.
Can you hear me now, John?
I can.
Oh, great.
Yeah,
Yeah.
there we go.
Good stuff. Yeah, I had to go into my system settings here. For some reason, the microphone was turned down.
Oh,
Yeah,
yeah. That stuff is always something. It's always something. You got to be on top of it all the time. It's impossible.
absolutely. How's it going this morning?
It's going good. You feeling better?
Yeah, I am. Yeah, thanks for asking. Yeah.
Okay, good.
I'm gonna go grab my cup of coffee before you get started.
Okie Okay, well, I'm going to go ahead and get moving along. I see about 8 of us in here, a little low today. Hopefully, we'll get a few more coming in. It's important for us to make sure that we make it to class on Wednesday because we got behind and we've got all those worksheets that we're supposed to be doing. What I like to do is do those together with you guys. So you're not completely on your own working on those things and not lost. So Wednesday for everyone, especially those of you guys that aren't here, make sure that you're coming to class on Wednesday so we can get those worksheets done. They seem really hard, but when we do them together, they're not bad. And some of them are pretty easy. It's just a matter of those are our activity sheets to go with our lessons. Okay. All right. So if you go home, you'll see we are getting ready to start week 4. And what we have is workplace safety and rigging for today. And that's going to be wrapping us up for safety. So we've done a lot of safety stuff with Competent Climber Tower. Not really going to be able to do a midterm exam this week or next week because we got a little bit behind and we got to get those worksheets done. So we've got some little bit of catching up to do. So don't worry about your midterm right now. Just worry about getting all your homework caught up. It'd be easier, Roberto, if we just work on them together in class. You just got to do your longitude and latitude, and they're hard to read. That's the problem. They're not that big of a deal. It's just a simple activity that we can talk about together when we look at the maps. Those are some of the things that you may or may not get into when you're working in wind. There's different jobs that require different knowledge backgrounds. So, you know, surveying of an area, site development, that type of stuff. That's where knowing how maps work, knowing how to read elevations, and understanding, you know, things like sound issues. So I don't want you to feel overburdened with those worksheets. If you wanted to start them and get them going, and you have, that's great. That'll just let you get done earlier, and we won't have to wait as long on Wednesday, or you won't have to need as much help, because I'd like for you guys to just work on those worksheets and turn them in on Wednesday. So we'll have 2 to 3 of them that we'll try to knock out in the morning on Wednesday, and that'll get everybody caught up. If you're missing Wednesday, then you're going to be on your own a little bit more. I'll still be able to help you, but you know, those are part of our lab. And then we still have plans on trying to do rigging and climbing on Wednesday. So for those of you guys that know, probably want to wear boots if you can. We'll just see how it goes and how things go since we lost a whole day. Okay, an on-campus whole day, which is an important one for us. Okay, is there anybody had any questions for me before I get started?
No.
No, don't bring those, don't print those off. I already got them printed off. You know, if you wanted to, because you were stuck home, you could have printed them off and brought them with you. But if you, you know, already printed it off and already did the work, bring it with you for sure. I don't want you to have to put a bunch, like there's some of them are 10 pages long. I don't want you to have to upload them as a submission that way. You can hand them in to me as a submission, and then I can just get your grade recorded right there. That's kind of the best way to do it with these worksheets, because sometimes they're a little confusing and you need a little bit of help. Sounds good. Okay. All right. Yep. So if we were to go to our syllabus, I'm going to scroll down, so watch your eyes. You'll see that we are in workplace safety, ropes and rigging, and we'll be needing to do, week 4 is really developing a preventative maintenance program and lubricant. So see, we're a little bit behind. So we'll work towards that next week. And then after that, we'll probably end up taking our midterm. So I'm gonna have to make some adjustments to our syllabus here. I might just make one that's a little more clear and not quite as generic, but we'll have to make changes as we go when we have snow days. Okay, so if you click on workplace safety and rigging, I wanted to add a little bit more to this lesson, but I feel like this lesson has plenty in it for you to do. And I want to make sure that we're not piling on more and more work until we get caught back up. So we're going to cover chapter 3, and then we also have rigging PowerPoints that go with this. So they're not very long. It's just one set. And then we have, you still have a section 5 left in your fall protection, wind energy competent rescue training course. And that's okay. That's got a little quiz that goes with that too. So you have your regular assignment that goes with your chapter. You have a shorter quiz that goes with your rigging lesson. And then the fall protection section 5 quiz. So those are all in Canvas, and you should have multiple attempts on those, and you should be able to work through those just like normal. And then of course we've got another worksheet that goes with chapter 3, and that'll be a worksheet that we'll try to work on Wednesday along with everything else if we can get it done. You have the learning activities is just think about rigging, think about your knot tying if you haven't done that. Hopefully we'll have more time on Wednesday to get back over to the climbing lab, and then we'll do some rigging practicing while some of you guys are working on rescue training. In other words, just how do you get out of a tower, use a roll gliss, and look at SRLs, some of the other equipment that we want to wrap up talking about today. So these PowerPoints are pretty simple. I'm not going to use them. I'm going to go back to the textbook here in a minute. But what we're discussing today is safety programs, electrical systems, mechanical systems, rigging, hot work permit, confined space, chemical safety, material safety data sheet, environmental work hazards, and offshore wind projects a little bit, which I don't know much about. It's just a little bit that's in your textbook, but that's what the lesson is today. So I will shift over to our textbook. Let's see here, I got somebody else that came in. Rory, let me get you, Rory. Okay, so this is chapter 3. I like to use this book. I'm still not sure if any of you guys are able to get your book yet. If there's any questions on that, we can talk about that on Wednesday. And I can try to dial that in, and we can look online and see where there's books, or you can get it at the bookstore. But as of right now, I'll continue to try to go through our Zoom meetings with my book open to help you out as we go along. So mostly what I want to do is just highlight the tables that they have inside the textbook and talk about some of the objectives. If you've had safety before, which I think most of you have had it, it's going to be basic safety, so it's going to be fairly easy. I didn't want to give us a huge overwhelming lesson here. So you should be able to go through it a little bit easier than something that's a little more complicated. But if you've never had safety, this is some of the things in here are specific to wind. So we want to talk about what that stuff is and make sure you're aware. So as we know, when we're dealing with wind in the wind industry, we have the Occupational Health Safety Administration, ANSI, and we have several examples of industrial work hazards. So what are those work hazards? We've got electrical with shock, electrocution, arc flash burns, We've got arc flash equipment at the lab that we can look at on Wednesday. Mechanical, which would include pinching, crushing, entanglement, laceration, and possibly amputation. Anything that's spinning, gears, stuff like that, we know it's very dangerous. You want to be careful around. Same thing with rigging. When you're lifting things, you can get your body, your hands entangled in the rigging, or something fall down, hit you in the head. Fluid power, we've got to deal with injections. Injection would be if a line bursts and squirts you with hydraulic at really high PSI, it can actually get under your skin. You know, burns, fluid power can be hot, poisoning. That's if you were to drink it, which is unlikely. Environmental controls, we've got to worry about things that are around us all the time, which would include weather and animals, or your outside environment. And we've got to worry about hot work permits. Some of the, we don't do really any welding and hot work permits very often in wind, so I wouldn't worry about that too much. You have confined space where you do need to be concerned about being out in the hub. And so there's the rules on how many people are going to go. And of course, offshore would be anything that's out in the ocean, hypothermia, frostbite. Okay. So the text goes on and talks about electrical hazards, making sure that you understand what type of PPE that you're supposed to wear when you're working around certain hazards. Make sure you know what the National Fire Protection Association, or the NEC code. That's what the NEC code is. National Fire Protection Agency 70E is the NEC code, or National Electrical Code. One of the things that's important is planning. We've got to make sure that we are working with our staff and our management. So we've got to determine what the hazards are in the work environment. And we do that generally with a JSA, or job safety analysis. This is an example of an activity here where we're talking about lockout, tagout, making sure that you have lockout, tagout on all of your equipment and you follow the proper procedure for lockout, tagout. So when we lock things out, there's only going to be so many people that are allowed to work on that equipment as part of the JSA. Okay, so this is just more or less, this first page is just talking about implementation and hazardous work environments, making sure that everyone's on the same page. There's a lot of safety fluff right here, talking about how people need to be responsible and take on safety for themselves, and make sure that you follow your safety programs and your policies and procedures. So that's mostly what that is talking about. And then it goes into your safety meetings, which is important. We're going to look at a JSA here in a second. Weekly safety meetings and daily tailgate meetings are valuable tools to reinforce the importance of working safely. So when I worked in wind, we had weekly safety meetings. Once a week, everybody would get together, and then we would also have a box, a suggestion box you had a suggestion box, you would say if you had some type of problem that you noticed was a new hazard, you could anonymously put that in the suggestion box. And once we had a weekly safety meeting, that's when the safety managers would talk about some of those new policies that may come out of a suggestion box. So suggestion box is something that I highly recommend. Okay, so monitoring. Here they're just talking about making sure that you are working with the right people and you are following through on your JSA. You're not just filling out the paperwork and ignoring it and not following the safety program. So there's always room for improvement, right? We definitely can, we don't want to sit back and say everything's perfect and wonderful. So safety is an ongoing process as you work in the field and as the policies change. It's a fluid thing, and that's what the tailgate meetings are for. So let's look at a job safety analysis worksheet. I'm going to switch this over to our modules. And if you scroll down to the very bottom here, you'll see a job briefing example. We'll click on that. So this is a job briefing that I used to use. Let's make sure we got 2 pages here. Yeah. And so, you know, when you were, if you were to work on this, this is the form that would be filled out every day. So things like the date, how many people are on the crew, the EMS number, which would be 911, 911, right? The wind turbine number, the exact location. So it could be wind turbine 37, wind turbine 28. What's the nearest medical facility? You need to know that in case you got to call someone. So that would be the hospital that's closest to you guys. Circuit ID and voltage. That would be if you're going to go work on that wind turbine or that circuit. Something that a lot of people don't know is when we see wind turbines shut down, we'll see several of them shut down at once. And that's because they're all on a circuit, just like a breaker. And we turn that breaker off, then we turn all those wind turbines off. And so sometimes there's more than just one turbine that's going to go down, depending on what we got to do. What is the specific type of work to be performed? These are things to consider. Walking the job and identifying hazards. That's always important when you get to the job site. If you've never been there, you want to look for holes in the ground. You want to look for things that were left by another crew that could be dangerous. You just want to be aware of your surroundings, especially if you're on a construction site. You also want to be aware of any stored energy. Do we have any anything we're going to be working on that might be hot? What about our trucks and our vehicles? Are we going to be able to get in there and get out of there? Like, for example, when you get all this snow, you got to be able to drive your trucks back there and be able to work your way to the turbine. So that's an issue there where it has to get dug out. Minimum approach, we'll talk about that in a little bit. That goes along with electrical. So this just gives you a list of things to think about, where you would write down your critical work steps, things that you would be doing for the day, things that you need to worry about, potential hazards, electrical, mechanical, what type of control barriers or PPE that you would be working on, names of people who are part of the crew that are going to be involved in very specific tasks. So that could be everybody, or that could be just, you know, you're in charge of this today, and this person's in charge of this today. Then everybody would have to sign off on it, and then you would go to work. If you were to show up at a wind turbine, then you would need to see the JSA and sign off on the JSA as well. So if you're a visitor, you would need to do that. If the job changed, if you had, say, a lightning strike, or you had to come down for the day, you might say yes, condition changed, or we had to stop work because of a storm, things like that. And then sign off and go with it. So that's a basic JSA. So any questions about JSA? Pretty straight. Yeah, okay. Pretty straightforward. All right, let's go back to our text. So now that we've seen a JSA, we don't really need to talk about it too much here. Arc flash, they're talking about arc flash protection in the textbook, making sure that you're aware of what is energized, what is not energized, as you're working around people who are qualified. So question is, how qualified are you? You know, coming out of a wind program, brand new, you wouldn't consider yourself necessarily qualified. You want to work with someone that is qualified so they can show you the proper way to lock and tag out things, and what are the techniques that you need to understand to work on the activity. So this is talking about the approach boundaries. So you have limited approach, where you can only get so close to the conductor, but not touch it, restricted or prohibited. And so that's going to be listed in your. So here we're talking about the voltages. So when we're dealing with different voltages, 3 feet, if you're dealing with 0 to 150, if you're dealing with something that is 75,000 volts or higher, which is really, really high, you know, they want you to stand, you need to be like up to 12 feet away, depending on if you have exposed parts. So condition C would be exposed live parts on both sides of the workspace without guarding, and the operator located between parts. So that condition C would be the most dangerous that there is. That stuff is what minimum approach is. A lot of people think minimum approach means like your truck, you drive your truck to work and you only can be so close. What does minimum approach mean? We're talking about being close to live conductors and exposed live parts. Okay. So we know we need training for that. And whenever we're working around electrical equipment, we're going to need an electrical work permit, which is pretty much what your JSA will be. It's going to depend on the work site and your safety policies. They may have more permits for you to fill out as part of their company policy. Next, we're talking about the HRC, or hazard risk category. So when we look at this right here, we're really just determining what level of hazard this is, because, for example, equipment rated below 240 volts, such as a circuit breaker, work with energized conductors, including voltage testing, removal, or installation of a circuit breaker, very basic electrical work. You're talking about an HRC of just 1. Then when we get into stuff that you're going to be working with most of the time, where you're going to be working around energized conductors that are around 600 volts, then you're getting into an HRC2. 600 volts, then we go all the way up to 38,000, where you may be working on a transformer or around a transformer. So the HRC categories is telling you what type of clothing that you need. So if it's HRC 0, you just need flame resistant clothing, untreated natural fiber, long sleeve shirts, safety glasses, your typical hearing protection, work gloves, and safety shoes. It's not an arc flash equipment. HRC 1 is arc resistant shirts, arc resistant pants, coveralls. Once we start getting into HRC 1, HRC 2, HRC 3, then we're going to need to be considering that we need to wear an arc flash clothes. So you can still wear a long sleeve shirt and pants. It doesn't have to necessarily mean a full suit, but 4 cal is about the minimum that you can go there. So that's the rating of this of the clothing, 4 cal. Then you'll see the rating 8 cal goes up, HRC 2, HRC 3, and HRC 4, 40 cal. So that's full blown arc flash clothing. Then you have gloves. Gloves are pretty easy to understand. You have your different voltages for your gloves. So different colors, as you can see, the type of voltages that they can handle. Beige gloves. These are rubber insulated gloves, gloves that would go over your hands, not regular gloves. These are gloves to protect you from electrical shock. And they'll have their numbers stamped on them like that right there. Tell you what rating they are and what color they are. Lockout, tag out, pretty straightforward. It means you want to turn the machine off. You never want to work on stuff that's energized if you can. A lot of times you have to, but in most cases you don't. You just need to be aware that it's not normal to work on hot stuff unless you absolutely have no other way. So that's why we work on things in lockout, tag out procedures. Okay. Does anybody have any questions about lockout, tag out?
I guess my quick question would be, obviously that would be something that only a select few people would be trained to do.
Yeah, or most everybody is. I mean, you would have a lock, and for that day, let's say you would go work on wind turbine 25, and you would shut off the main circuit breaker to the wind turbine 25, and you would put your lock on that circuit breaker, and your name would be on it. And that means only you or the approved supervisor should take that lock off. No one should ever do that. I'll give you an example where I got shocked once, where I did not lock out my breaker. I was working on a switch, and it was just a very simple electrical switch, nothing that would have been too dangerous, but I still should have went to the circuit breaker and locked it out. While I was working on it, my boss went over there and decided to turn it on and shock me, which is kind of weird, you know, thinking, why would your boss do that? And one of the inspectors was actually there that day, and he watched him do it. And so that was just a real eye-opening for me that, you know, nobody touched my lock, and make sure that everyone understands that this is staying locked until we get done with that activity. So there's just a little case study here. I'm not going to read that. Talking about an incident here of someone who ran a pump, and they thought that they would skip some of the procedures. And, you know, this is telling you all the procedures, the company procedures that you're supposed to follow for running a pump if you're changing oil in a wind turbine. And one of the guys in this little case study decided to take a shortcut, and he shocked someone. So the contract technician thought that the process could be sped up by reversing the pump motor direction by swapping 2 to 3-phase conductors, but this was not an approved procedure for doing that. That's just something that that person thought that they would do. So that's why it's important for you to follow your procedures and know what those are. And they'll be in a book, and you'll have those procedures on your computer or a book, you know, same idea, where you get into your file and you look, okay, so for this activity, we need these tools, we need this stuff. Mechanical systems. Mechanical systems are going to be drivetrain, blade pitch. That's one where if you're out on top of the wind turbine, you've got to be careful. I've seen pictures where a guy got his leg caught between the blades in the nacelle. He walked up there while they were spinning, and he slipped, and he put his leg right in there, and it wasn't good. It took a big chunk out of his leg. So you know, you're not thinking about some of these things. That's the whole point, is look around you. What kind of mechanical systems are around me that can cause an injury? Like your gearboxes, you wouldn't think about the blade pitch necessarily. Fluid power, hydraulics, your antifreeze systems, heating and cooling, all those systems you got to think about one step at a time. Okay. Let's move on from that. Types of hazards. So drivetrain, what you basically want to make sure is you don't have loose clothing, you don't have necklaces, long hair, rings, anything that can get caught in the drivetrain or the gearbox while it's moving. Same thing with the brakes. The brakes have calipers on them where they squeeze to slow down the wind turbine. Putting your fingers in the brake pad while it squeezes down obviously is a crushing or a pinch point. So if you're working with your brakes, you want to make sure everything is shut down, so you're not going to get hurt in that way through a mechanical hazard. So mechanical system hazard. So all we're doing is just trying to take some time to think, what kind of electrical hazards would be in a wind turbine? What kind of mechanical hazards might be in a wind turbine? Crushing hazards. What should I be thinking about that I haven't really thought about before? This is a nice little chart here that shows you basic PPE that you would wear on some different activities, such as torque inspection of tower flange bolts with your bolting tools. So you're just tightening bolts with a hydraulic press. So in that case, you would wear safety glasses, safety shoes, cut resistant gloves, hard hat, full body harness if you were working up top tower with your lanyard, of course. Any of those types, on appropriate work clothes for the the temperature environment. A different activity would require different PPE. That's the point of this. But in most cases, it's going to be your general PPE. When they're working on electrical stuff, the PPE switches to the HRC, you know, your fire resistant clothing or arc flash equipment. So we know we're always going to be wearing our general PPE. Noise levels, we need to be protecting our ears. 85 to 90 decibels is about the cutoff. So if you're working with power tools, you need to have hearing protection, because the power tools can have way more than 100 decibels in their sound. A movie theater is about 105 decibels. So, you know, that's why we can only sit in a movie for about 2 hours. If you go too long, you can get hearing damage if you have the sound turned up too loud. Hand tools. Inspect your tools before each use. Make sure that they're safe. Things like working with insulated tools, you got to be careful that the insulation on the tool could get damaged, so it's not necessarily there to protect you from electric shock. Power tools, as we know, they can definitely hurt you. You want to inspect them for damages. You're going to be working with battery drills a lot, possibly presses. This is that's just a drill press. Hydraulic. This is a hydraulic torquing tool right here for tightening big bolts. These are grease guns, electric battery powered grease guns. Those are common. And this is a torquing press for big bolts. So we actually have this, and we have this in our lab. So we'll be trying these out. So not much to it, just inspect your tools. Look for things that are bad, such as your wiring. Can't use that stuff. Make sure it's safely done. Rigging. Same with rigging, making sure that you inspect all your web straps, your chain hoists, your cable slings, your rigging equipment. You need to make sure that they are in good condition, just like your harness, before each use. So that's all that really is talking about. Make a habit of inspecting your rigging components. This is important because when we have lifting guidelines, I've seen a lot of stuff fall down tower. So let's take a look at this. So use a lift bag rated for the weight of the tools. So you're going to have a hoist crane come down the tower. It's going to send a chain down the tower, and then you're going to hook it up to a bag. And if you're hauling up a piece of equipment or a tool, you want to try to use a bag. You don't want to try to just hook things onto the chain hoist. And then you never want to exceed the bag rating. Obviously, I've seen bags go up the tower and they just rip out, and then down comes a tool. I've seen a hydraulic press fall down the tower and damage the tower an enormous amount. It fell and smashed into some of the equipment and the computer. So, you know, slow down. Think about things like sharp edges. When you're lifting your bags, make sure that they can go through all the hatches safely, that they don't get caught on a hatch. When we're talking about a hatch, we're talking about when you're lifting it through the middle of the tower, you got all the holes in the middle of the tower. You've got a place where you're pulling up your equipment, you might need a tech on each deck to watch the bag go all the way up and the tools to go all the way up to make sure that they're not catching on any snags, because they'll tip the bag and dump it on somebody's head. Okay, so that's a good thing to read through. There's your hoist. Generally, it's going to be at the very top of the tower. Some of them actually are on the back of the tower, so you got to open a hatch and lift from outside. Some of them are inside the tower and they lift inside to outside. I'm sorry, they lift inside only. These are some of the types of rigging that we're going to be working with. We've got a PowerPoint that's going to give us a little more detail over this. So we've got just chain straps, slings, knowing how to use those, basic lifting safety tips, lift with your legs, not with your back, things along those lines, making sure that you understand how to lift heavy objects. Try not to lift things that are more than 45 pounds, 50 pounds. Never exceed the load capacity of the lifting components. Okay. Fire safety plan. All that's going to include is just fire resistant blankets, wearing your fire resistant clothing if you're working around any hot work, any type of combustible gases, welding particularly. You don't have a whole lot of that in wind, so it's not that big of a deal. But they do run you through the fire extinguisher. Make sure you know which type of fire extinguisher to use. So for electrical, we use a type C. They've got a nice little chart. This is a hot work permit. So grinding, cutting, welding, riveting, anything that's going to throw out sparks or fire. And you got to be careful of that too. When you're grinding or cutting, you want to be careful around your harnesses. That's how they can get damaged. This goes on talking about pass. Remember how to use a fire extinguisher. So pass means pull the pin, aim near the base of the fire, squeeze the trigger, and sweep side to side. Basic fire safety there. There are your fire extinguisher classes, Class A, Class B, Class C, and Class D. So you do want to pay attention to which ones these are. Next, we talk about having an evacuation plan in case there's a fire. So how do you get out of the tower? What type of safety gear do you have? There's just basic fire extinguisher work. Pull, aim, squeeze, sweep. Confined space. So confined space is important because you need to make sure there's enough people that are working with you. It's not a one-person job. It requires three. Requires one person to be at the top of the turbine, if that's where the confined space is, which A lot of times the confined space is going to be the hub. If you go out into the hub or out into the blades to do some work on pitch motors or on bearings, bolt tightening of the blades, that would mean one person would need to be at the top of the nacelle, not in the hub with you, but an attendant at the top, and then you would need someone at the bottom of the tower as well. So a lot of job safety policies require a confined space permit. What would those be? Wind turbine blades, underground electrical vaults. Then it just goes into some random stuff here. You shouldn't have too many confined space. This is an example of confined space entry plan. So here you can see the technicians, a minimum of 3. You have the entrant, you have the attendant, and then you have ground support. So this is just showing you some steps that you would go through to do an activity of a confined space. So shut down the wind turbine, lock out, tag out, make sure that you know what is going on with the weather, because if you get in a bind, like you're out in the middle of the blades working on it and an electrical storm comes with lightning, you got to get out of the tower, and you'll be in a bad place if you can't get out of the tower fast enough. Atmosphere testing. If you're ever working where anything is that you need to have a sniffer or a type of scuba type device, and what we're talking about is a self-contained breathing apparatus if there is a hazardous atmosphere. So low oxygen is what we call hypoxia. So they'll talk about some of these conditions here. Okay. Back up to the top. It's your scuba. So this is giving you an example of where you might have gases. Hydrogen gas can be produced during discharge of battery backup systems. It's very unlikely that will happen, but you could have hydrogen gas build up inside the hub if the batteries are producing any type of gassing. They shouldn't be most of the time, but that's just something to think about. You want to allow the gases to escape. That's just not common because the batteries that they use now typically are sealed and they don't gas. Okay, I'm going to pause here for 1 second. I need to use the restroom and I'll be right back. Just give me a moment. Okay, sorry about that. So here they're talking about the basic training that you need for confined space. And then we move on to showing that there's more than one person that is needed for confined space, such as an attendant or an entry supervisor is responsible for confined space activities. So those are just some of the definitions there. So how many people do we need for confined space? You guys remember?
3.
Three. Yeah. All right. Just make sure we know that. Okay. Obviously, we should have a rescue plan that includes first aid, CPR training, anything that you would need to do in case there's an accident in a confined space, your basic training, rescue plan. Chemical safety, if you're working around chemicals, we've got material safety data sheets to tell you what is about the chemical, how to handle the chemical in your hazard communication material. Talked about being trained using the chemicals first. Make sure you know what you're working with, know where emergency contact information is, eye wash stations, anything like that. You don't have eye wash stations in a wind turbine, but you do have water bottles. So we don't get into MSDS stuff too much here. It's just different classes of MSDS sheets, examples of hazardous material information. So explosive, compressed gases, flammable liquids, flammable solids, poison, radioactive materials, anything that might be dangerous, cancerous, things along those lines. They're supposed to be labeled and you're supposed to be aware of them. And the fire extinguisher method for dealing with those chemicals, proper PPE, proper cleanup method, handling methods. That's training. Okay. Environmental work hazards. So we can speed this up just a little bit here. Most of this is just talking about, oh, they don't get into it, but considerations such as the environment, temperature, working outside, making sure that you have the appropriate work gear on, thinking about wildlife. We'll talk about that a little bit more. The weather systems, weather is a big one. Let's see, you got a chat here. Yeah, I'll have all the worksheets printed off for us, Roberto and Landon. I think I saw an old chat or something there. Just trying to answer. So some of these warnings, whenever there is lightning within 30 miles of the farm, there's the key right there. So if there's a lightning strike within 30 miles of the farm, that usually means it's time to get out. Usually every wind farm is going to have some type of lightning detection system. It's either through it's going to be through a weather system that they're watching, and wind farm managers should be watching. You should be watching, especially on days where we have scattered storms. You may be going up and down the tower a lot on a stormy day. severe weather goes beyond, obviously, just lightning. You know, any high winds, we generally don't go out of the tower when winds are starting to get higher than 45 mile an hour. That's getting to the point that it's getting too windy. You've got to worry about snow. We see a lot of snow outside right now. You've got to worry about snow building up on the blades and turning into ice. If you're working at the bottom of the tower, that ice can slide off of those blades, and we know that can hurt you. So you need to be aware of things like that. So environmental hazards, think about those things. Freezing rain. You're climbing around out on top of this turbine and you've got everything covered in ice. It's going to be slippery. I've slipped on top of the turbine before in freezing rain. I didn't fall off the side, but I slipped and fell on my butt. And that was pretty scary for me. So, you know, be careful. If it's too slippery, then sit down, scoot if you can. Try not to just walk across ice on top of the turbine. Then we get into cold weather exposure. Make sure you know how to get your proper cold weather gear. Working outside when it's freezing cold is probably the #1 thing I hate more than anything that I did when I worked in wind. I just don't like to work out in the cold. So make sure you've got Carhartts and long johns and good boots, gloves, all that stuff to keep you nice and warm. Thick socks, toasty toes, you might need those. Most of these turbines are going to have heaters inside them. They're still going to be very cold though. So you've got to worry about things like hypothermia. You're getting too cold, start to shiver. I worked on top of, I was in the hub in West Virginia working on a GE wind turbine on top of a mountain when it was -10 degrees below. That was cold. That was very cold. And that was about as cold as I think I could handle. So you might, go ahead.
High up were you?
300 feet.
Oh, wow.
So it was even colder in the air because you're even higher up and you're out there with the wind. That'll wake you up in the morning for sure. But that's the worst of it. Then you have the beautiful days where it's sunny and wonderful and you're out there working on top of the turbine. It's like the best place to be, all by yourself. Wonderful day. So there's a little give and take there. So hypothermia, frostbite, that's a big one. We know what frostbite is. Make sure to keep all your fingers and toes warm. That's why if your feet are getting too cold, you might get the little hand packets to put in your pockets or put in your boots, the warming toasty toes. They usually will provide those when it's extremely cold outside. And you should have a truck, a vehicle you can get in and get out of and turn the heat on to try to stay warm. We're talking really cold. Most of the time, you guys are going to be working, and what they say is the heat's in the tools. So if the heat's in the tools, that means, you know, you're going to be sweating and getting hot anyway, as long as you're staying busy. But on those extreme cases, you've got to worry about that. Speaking of sweating, we have to deal with possible dehydration in both hot and cold weather. So make sure that you're drinking a lot of water. I think dehydration can be a problem in wind turbines because there is no bathroom and people don't want to have to go to the bathroom, so they won't drink enough water. So you need to be, you need to learn how to try to be as regulated as you can. When you go to the bathroom, you go to the bathroom in the morning, so you don't have to go to the bathroom when you're out there working in the turbine. There are, if you do, you'll just have to see what the other people are doing. You know, I hate to say it, but a lot of people, they use a water bottle if they have to go to the bathroom in. If you're a girl, you use a Gatorade bottle, something like that's a little bit bigger than a small water bottle. But I mean, that's a common thing that happens if you can't get down. Always have a little water bottle with you. That's one of the things in wind I don't like. But I found when I was working, most of the time I didn't have to go to the bathroom when I was out there, just because I made sure I went to the bathroom whenever I had the chance. When I was down at the bottom of the tower, in the office, before I went to work, as much as I could. So dehydration. There's hypothermia, heat stroke. We're talking about now. You can work out there when the temperatures get at 100 degrees. You got to remember you're working in a turbine that is a metal tube. The sun's shining on the metal tube. Everything's going to start getting warm. So I don't remember that being nearly as bad as the cold. So the heat didn't bother me as much as the cold, because you can work in a t-shirt most of the time. But there will be those days where you got a lot of gear on and it's hot, and you got to be careful about hypothermia. Hyper versus hypo. We shouldn't get too much overexposure to the sun. That's something to consider if you're working in solar. Wildlife hazards. Wildlife hazards are real. I've seen cougars, I've seen bear, I've seen plenty of deer, I've seen different types of wildcats off in the distance. Nothing ever threatening me, but driving my truck up through some of these areas, the animals are there. The things you really got to worry about are the insects. I mean, just being outside, you got to worry about getting stung or a spider. Only I wouldn't worry about scorpions or anything like that unless you're in those odd areas. But if you got an allergic reaction to it, that could be bad. That's why you might need epinephrine or an EpiPen if you have. Some people can't get stung by bees, so everyone needs to think about that. Spiders, brown recluse spiders, things like that, that might be in there that can bite you. They can damage your skin with a bite. So if you get bit or stung, you really need to go deal with it. If it's a mosquito bite, that's one thing. But if you get stung by something like a hornet or a wasp or a spider, yeah, you might want to call it in and go get it taken care of, just so you don't have a problem. You especially don't want to ignore nasty spider bites, because you can get some pretty nasty scars from those if it's like a brown recluse. I've never seen any reptiles except snakes. So, I mean, just snakes is what you got to worry about. In the tower, no. Outside the tower on the ground, yeah, I've seen them. Offshore projects. So offshore projects are something, again, I don't know a whole lot about because I haven't done that. What you're looking at here is pictures of wind tech wearing cold weather gear in case they're out there in the water, trying to put on something like this to prevent hypothermia. I'm not entirely sure how that would work, but I know that whenever you're working in offshore, you're going to have some type of training. So the book's kind of fun, and it talks about this stuff a little bit, making sure you've got exposure gear, cold water survival gear, personal flotation devices, rafts, things like that, that can help you survive until you, and like, why would you be in the water to begin with? Well, we're talking about if you on a boat trying to go out to your wind turbine, or you're in a helicopter trying to go out to your wind turbine and you have an accident, the boat capsizes or the helicopter crashes in the water. And so there, you give you a nice little list. Distress beacon. We don't have really any offshore wind in the United States. It's just starting to come. So it's not too much of a concern unless you plan on moving to Europe or going to the West Coast.
Hey, John, you think like politics has a lot to do with that?
Yeah, people don't want to see them.
Yeah, I noticed reading the text that there was no mention even in the section where it was talking about reasons for um, or influences on wind energy development. They never mentioned
Yeah.
climate change, not one time. Uh,
Climate change.
yeah, I thought that was kind of
It
ironic.
is. It is. It's definitely, climate change is definitely a reason. We know that.
Right, yeah. So it seems like the politics. I for my thesis capstone for my bachelor's degree, graduated in May from Holy Cross with a BA. It's a
Yeah.
liberal arts degree, but my thesis was about why Indiana has failed to set like a mandatory renewable energy standard.
Right.
They do have a voluntary one, but obviously, it's like a mandate, right? No one actually participates in it. Um,
It's a good question though, and a good point. They're bringing a new law. I don't know if it'll pass. I think it's called HB 411.
okay,
HB 411 in Indiana is trying to get counties, instead of trying to do the whole state because of the politics,
yeah.
counties that are renewable energy ready. So we passed this law. It'll allow certain counties to zone everything and say to developers, we want solar and we want wind in our county. And so it doesn't matter what else is going on in the state. That's one way to get around that. That's a new law that's kind of coming into play.
Oh, that's
I
pretty
don't
cool.
know.
Yeah,
Yeah.
what you think Lafayette will jump on board with that? I did read an article where a few years back they kind of were against some wind turbines going up. The NIMBY
Yeah.
effect is what they call it, NIMBYism, not my backyard.
Yep.
This whole thing
Yep.
about the blight that wind turbines would cause, on property values and things like that.
Yeah, the problem with Tippecanoe County is it's a city county. So they want to develop the city and grow the city. So you're working against that. So like they don't want to take up the land and put a power plant on it
Mhm.
because they can sell the land and build more shopping malls and businesses and neighborhoods because of that. Find a much easier time doing development when you're in areas like White County or Benton County where there isn't a really large cities there. That's one of the
Rural.
problems.
Yeah.
So Tippecanoe County, yeah, there, but that's okay. Everything around Tippecanoe County seems to be open to it.
Mm.
And Tippecanoe County is only got so much space for wind anyway, but you never know. You never know. Let's see here. So lastly, when they're talking about helicopter stuff here, um, they're just talking about ditching the helicopter. I'll let you read about that. We're almost done with this chapter here. Ditching the helicopter, meaning that they crash, just like in a car. If it says, do not panic, wait for the cabin to fill with water before preparing to exit. As long as water is being forced into the cabin, you will not be able to control your position. Having your seatbelt secure will keep you and other occupants from being forced around. becoming injured. This is the same advice given to passengers that have a car that's been in the water. So, you know, you got to let the water fill in before you can swim out, is all they're trying to say, or you don't want to be pushed out. I don't know. Some of you guys have been in the military and stuff know a lot more about helicopters than me. That's just something that was in the text that is somewhat interesting. And water hazards. Okay. So that would just be dealing with animals in the water, jellyfish, sharks, things like that. That kind of gets a little scary when we start thinking about it that way, but most likely you would be in a raft and a flotation device. All that stuff, again, would require specialty training. Okay, so that's going to wrap us up for, then we'll be getting into lubrication. Well, that's not necessarily the chapter we're going to get into lubrication really soon, but that wraps us up for our textbook. Now let me go back to our modules. So that was chapter 3. And we've been going for a little over an hour, still got a little time left. I want to back up a little bit. I want us to look at this rigging PowerPoint, and then you've only got a few short questions. You got 8 questions over section 5. So let me explain, what do I mean by section 5? So when we get into your, this will be the last time we look at this fall protection training. You guys have done this already. That was the first thing, one of the first things we did. We went through section 1, section 2, section 3, and section 4 together. We didn't go through section 5. So section 5 is really, only thing in there that I'm really concerned about is self-retractable, or SRLs, things that we talked a little bit about already. So make sure that you read through section 5, and let's just take a peek at it. So I'm going to scroll. So there you go. So it's on page 35. So you should see section 5, specialized equipment. So what we're looking for is self-retractable lines. Hold on a second here. Self-retractable lifelines, that's what an SRL is. We'll use those when we get into the lab. There's really not much to this stuff. It's just making sure you know what an SRL is. And you don't have to read all of this information in here. You just need to be aware of what an SRL is. Okay. So this is only a few pages long. Mostly talking about swing fall with SRLs. So when we're dealing with swing fall, the further up you go with a distance, and the further you get away from the top of that, the more you're going to swing. So rope grabs, cable lines, cable glides, we've already seen those and read those, used those in class and read about those. So should be pretty easy. I wanted to make sure that you guys finished up this book, because the last section is really, we've already covered most of that stuff. So they talk about ladder safety. We've already talked about ladder safety. being careful of a ladder cage. We don't have any of that. Cable ladder safety system, we've already used those. And vertical or horizontal lifelines, which we won't be using either. So most of that stuff you can kind of breeze over. If you have a question over it, you might look it up, but you shouldn't have anything really in there except knowing what a horizontal lifeline is, knowing that it stretches across a flat roof and you can hook onto it, which we don't have that in wind.
Now, I know we got we have a vertical lifeline in the lab, right? Is that something that won't be realistic to win? Or on the
Yeah.
tower, I noticed.
Yep. Yep. That's what we have. Yeah. Yeah. And, you know, we get into some of these extra supplemental information. It starts to get to be too much information. I'm just trying to pick through it and get you guys some of the important things that are in this book before we toss it off to the side and move on. So you don't need to know all of this stuff. Just worry about the questions that if you want to read through all this stuff, go right ahead. But there's just a few questions over SRLs in section 5. Okay. Let me know if you have any problems with that. Let's get into our rigging. That one we want to take a little bit more time to look at. Yeah. Rigging PowerPoint. So you should find the rigging PowerPoint. This will be the last thing that we go over today. And really, rigging has to do with understanding weight and balance and the limitations of your eye bolts and your slings. That's what we'll be practicing. So the capacity rating of the weakest individual components in a rigging arrangement determines the lifting capacity of the whole arrangement. So when we're looking at this, the hoist capacity rating is 10,000 pounds. The sling is 2,000 pounds. The eye bolt is 5,200 pounds. But because our sling is only 2,000 pounds, then the lifting capacity is limited to 2,000 pounds. Pretty simple. They've got a couple different sheets in here. Some of them are a little more useful than others of the different types of, we don't really use this one right here, so I wouldn't worry about that. Talking about the density of the material, which is better, steel or wood. Well, steel is going to be better, we know that. But what we want to do is we want to use OSHA rated, ANSI rated straps and slings. They'll have their weighted capacity on them. We have quite a few of those in the lab that we'll use, and we've got a little crane hoist that we have back there by the tower where I'm going to challenge some of you guys to lift some oddly shaped weights. Not so the complexity of the shape is something to think about when you're looking at it, because what you're trying to do is find the center of gravity. So if you were lifting something that's in a cylinder type shape, you're trying to look at the total diameter, the total height, trying to determine where the center of gravity is of the object that you're lifting. And this is what I mean by that. So this is what will happen is you'll have something that isn't a perfect shape, like a square. It's going to be oddly shaped, and the center of gravity isn't necessarily in the center. So if you rig it up improperly while you're lifting the load, it'll slide right off and fall. So balancing the load, one of the tricks is to try to rig it up and then lift it a little bit and see how balanced it is. Here's a couple examples of different types of loads, like a motor or a couple oddly shaped things that you would have to take up the tower or lift. Where is the center of gravity? It may be right in the center, such as a symmetrical load, but asymmetrical loads, center of gravity is going to be based on how heavy is this side versus this side. Balance can be checked by lifting the load slightly and see if it's level. So you can see in this case, you connect to this lifting point, the center of gravity is over here. So this thing's now going to tip. So you have to do a different rigging technique. You may use slings or straps. In this example, we see how we have a couple different ways where you could lift it. If you lift, say, from just the pallet here, then this thing's top heavy. So you want to think about the shape of it and whether or not it'll topple over. So you can see how having lift points here and here versus here and here could be better. And if you have eye hooks or eye bolts, that's something that you want to look for. Usually you can find those on certain things that are meant to be lifted regularly. But still, you may have to put an eye bolt on or in it to lift it properly. And you need to be aware of your lifting forces, where they're coming from, making sure that they're not unequal. Eye bolts. So the trick with these is whether or not they have a shoulder or not. You really don't want to see any threads sticking out. So these need to be put in all the way. The threads are going to be not as strong as the shank. So they're talking about countersink an eye bolt into, say, some wood. If that's what you're using to lift, like if you're going through a pallet or something. Make sure the shoulder is tight against the. And then here we start to see that the way that we lift, most eye bolts are designed to be lifted straight up and down. When we have angular forces on an eye bolt, it's going to decrease its lifting ability quite a bit. So this is showing you a couple proper ways of putting eye bolts on. through, looks like wood or metal. Shoulder up tight. Washers. This is where the angles come into play. So if we're lifting straight up and down, then we're at 100%. But if we start to now lift at a 60 or a 45, then we have to limit our capacity by up to 75%. So every time we pull on this, it's going to bend this way. That's not the way eye bolts were meant. You can still use them, but you've got to back off on the load limit a little bit. So here they have an eye bolt size. Depends on the size of the eye bolt. In this chart, you've got a 1 inch. If you're at a 45-degree angle versus a straight up and down 90, then it's reduced significantly, down from 13,300 down to 399 pounds, 3,990 pounds, I mean, and worse for at a 30-degree angle. So you can understand that. Any questions on that? What you're going to notice when you're using these eye bolts with the different slings, that they're going to naturally have an angle to them. Most of the time, things are going to be rated really high. And you want to pay attention to all of the components, like we said at the beginning. Like if we're using rope, what is the weakest link? Which one of these is losing its capacity? Mostly what we're trying to do is just get an idea of different devices that we use for lifting and rigging, what they're called: chains, shackles, eye bolts, hooks, and then be able to practice lifting those without making this too difficult. It's really a matter of balancing it and then reading and understanding how much something weighs, understanding this thing weighs 500 pounds. My sling can handle 2,000 pounds. We're good to go. Most of the time, you're not going to lift something that's 2,000 pounds. If we're lifting a gearbox, we're going to have, say, a crane. We'll look at an example where we do that. But you have a crane, and you're going to have specific eye hooks and eye bolts on that gearbox where they go, where it can be lifted properly. So those would be pre-engineered. But lighter load stuff, things that go up and down the tower, that's where you would need to be aware of different techniques, where you can use a basket for something that's round. You can use a choker method, straight up and down, vertical, or with your slings at the angle, and a bridle method. So we got vertical, bridle, basket, and choker. Not all methods are gonna, be the best for the situation. When multiple slings are used, the sling angle affects the increased forces on the sling. So smaller sling angles result in greater sling forces. So this angle is smaller than this angle here. And we know that the eye bolt is losing some of its strength. Okay, you don't need to know all this in this chart. This is just to give you an idea that you need to be aware of that angle. Whenever we have an angle, you know, we're at a 90 degree, but if we're at, say, a 45, you know, we're cutting things in half. And when we do this in class, it'll help you understand a little bit better of how to do this. It's not that complicated. One, there's tricks that you can do, such as when you have something like this, we can see how we're not stable, but you can put a spreader bar in there, and now we're a lot more stable. And we don't have the weight right here in the center of whatever it is. So this could be something, we wouldn't lift something like this up the tower. Not like that. And then lastly, when calculating the distribution of load weights in sling arrangements with 3 or more legs, this one is important. At least one of the legs is assumed to carry no load weight. As a result, the load is divided equally among the other legs. So one leg supports the entire load. If we have 2 slings, each supports half of the load. So each one of these needs to be able to handle 500 pounds if we have 1,000 pounds. If we have 3 legs, each must be capable of supporting half of the load. So they need to be able to handle 500 pounds. And that's if you have 3. So you wouldn't go 1/3 until you have, say, 4. So if you have 4 slings, each must be capable of supporting at least 1/3 of the load. 4 or more legs. And that's that. So that should just give you a better idea when we get into class on how to do some rigging techniques. I like to just put you guys in there and let you start lifting stuff and start grabbing slings and working through that. So that is all I have for today. Is there any questions for me before I let you guys go? Okay, well, I will see some of you at 1 o'clock. And then, of course, on Wednesday. And
See you Wednesday.
see you Wednesday. Have a good day, everybody.
Right.
See you later, John.
Okay, see you time.
You.